Okay. Hello, everyone. Good morning. Okay. Okay. So we will continue the continue our chapter 4, and I hope you guys have done the quiz. Okay, because I checked last night, still around maybe 20 students, but not only this class, the other class too. So combinations is 20 students haven't taken the quiz yet. So I hope you can take the quiz very soon because I think at 4 p.m. It will be the deadline for the quiz. And by 4 p.m. means if you take the quiz maybe at 3:30, if you haven't finished until the 4, the quiz will stop at 4 and then you will not get the complete results. So at least you need to take by 2 p.m. or before that. Okay, before that. Okay, so that's the quiz. And I think I can start with the feedback from last Monday. Okay. So we can start from discussing the review. And I hope you guys already scanned this QR code. Okay. And let's start our course. And let's move to the feedback. Okay. Now looking at this graph, okay, this is y equal f of x, okay, as mentioned by this question. So this is y equal f of x. Okay, I think it's the question is simple. At which point when y prime or the first derivative is negative and y double prime or the second derivative is positive. So it's asking when y prime is negative, which means less than 0, and y double prime is positive. Okay, so what you can do first, okay, as my suggestions is you can try to roughly imagine the slope. Okay, first imagine the slope at each point. So maybe A here and B like that, and C and D maybe 0, right? It's horizontal, and then the slope at E like that. So we know that from A, its slope is negative, B is positive, right? C also positive, D probably 0, and E is negative slope. Okay. Okay. And then what we can do from the curve also, we can write down the concavity. The concavity. So we can look at all this A from A. Okay, it's going facing upwards. Okay, it's facing upwards. Maybe until C. Okay, so maybe until or maybe until B like this. Okay, because you will see from B the slope is actually changing, and then also the concavity is changing, right? So concavity is changing, so it's going down, down. So concavity going down means it's concave downwards. So first is concave upwards, and second is concave downwards. Okay. Now concave upwards, this should be determined by the y double prime positive, and downwards will be y double prime negative. Okay. Now the question is asking when is y prime is negative and y double prime is positive. So the first derivative should be negative, and we get the point A. Okay. This is our answer, A. Okay. And I think you guys got to get a great result here. So you guys got correct. Any questions from here? I think it's quite clear. Any questions from this online students? Okay. From the class? I think okay, right? Okay. The next question is about now the graph is f prime or derivative of f. Okay. On what intervals is the function concave downward? Okay. So need to find concave downward. Concave downward is or in this case is negative. So you need to find the f double prime negative. But remember, we have f prime. So this is derivative, right? Okay. So when we are going to observe is the second derivative, right? The second derivative is the slope, okay, the slope of the f prime. So we can imagine the slope from here, from here, from here. Okay. So we know that the slope here is negative, right? Up until here, and this will be 0. And slope here is positive, right? And slope here is positive, 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 positive. So the questions concave downwards. So we need to find where the slope is negative. So it's from 0 to 3. And I think you did a good job here. But I think only 5 got correct. Okay. So, okay. So 0 to 3. That's the interval. So interval is 0 to 3. And let me write what you need to find here is find the slope that is negative. And we find that 0, 3. Okay. Any questions from here? Okay. If there's no question, let's move to the third question. Okay, third question, you're given the functions and consider graph inflection point of f is at x, not the graph. Consider the functions, should be just the function. The inflection point of f is at x equal. I think you guys got mostly correct. But let me go through the process. So the process is you can directly find the first derivative, find the second derivative, and okay, if you want to look for the domain, if you look at the domain here, the domain should be x is not 0, right? The possible domain, the exception is x, should not be 0. So that you need to keep in mind. And the first derivative you get, and then the second derivative also you get. And from the second derivative, you can check from here. And eventually you get x is actually equal to 3. But then to make sure that it's correct, you can check the 3 check the, remember you have 0 here, probably this is the vertical asymptote, right? And you can check from 1 or maybe 2, it will be negative, right? And if you have more than 3, it will be positive. So then it's correct that 3, the concavity is changing from downwards to upwards. Okay. No, not necessary any problem here. Okay. Okay. Any questions? I think it's understandable, and I don't think the derivative is difficult here. It's just a normal power rule, right? Okay, let me back to. Okay, anyone want to scan? Okay, let me give you a few minutes to scan. Okay, now if we go back here, actually I'm giving you these two curves. Okay, but I think I will explain this one. Okay, let me copy this first. I think for today I will just review the curve sketching and give you some example. But probably before we going to do that, I think I haven't told you about this yet, but let me just make up that for you. So if we have, let's say, if x cubed, x squared plus 1, okay, this form you can rewrite into using the, let's just define this. So this will be having the x plus minus x squared plus 1. So you can exchange this form, right? Okay. In this form here, this x here, this is we call the slant asymptote. This is not a vertical, not horizontal, but a slant. Slant is you have probably if I make if you have the curve, okay, this is precisely here. This is y equal x. And this will be the slant asymptote. So the curve, at some point, it will not reach the, or it will not crossing the y equal x. Okay? But the best way uh, to define the slant asymptote is if you have any random functions, like maybe say your curve is here, okay, like that, and you know that it will be having something here, okay, yeah, and let me write this as f of x, and the red line is our linear mx plus b. Okay. And between this f, the green and the red color here, we have a distance, right? Okay, the distance. And when you look at when x is going to the right, okay, to the right, to the infinite number, the distance between f and the line is getting shorter, right? Okay. Now, if we use in limit, okay, if we use in limit, so the slant asymptote, we can make this as definition as limit, okay, as x approaching to infinity from that picture, it will be 0. And that will be the definition. That will be the definition of the slant asymptote. So whenever you have a functions like x x squared plus 3 just like that, and maybe this will be x minus 1. And notice that you have degree 2, you have degree 1 here, right? The difference should be only 1 degree, so that you have line equations in the expansion, right? And that will be the slant asymptote. Okay, I think you can realize when you look at the functions, if the function has the difference at least 1 like this is degree 2, degree 1, or this one we done degree 3 and degree 2, so at least 1 degree difference between the numerator and the denominator, you will have the slant asymptote. Okay. Okay. And how to find the slant asymptote? You can simply divide and find through uh, the long divisions like this. You can find and then find uh, the slant and then the remainder from the division. Okay. I think this is I forgot to mention at the summary of this curve sketching. So aside from vertical asymptote that you might get horizontal asymptote, you can also get we call this the slant asymptote. And this is by definition with limit. The definition of slant asymptote, if you have the functions, you have the line equation, and when you uh, subtract the functions and uh, the line equations and getting x equal to infinite point or negative large is also correct. You can get the 0 result. Okay. Okay, that's a little bit uh, additional notes for slant asymptote. Okay, and sometimes if you have a rational function like this, if you maybe expand it with this separation, maybe you will find the derivative much more easier. rather than directly go to quotient rule. Maybe sometimes you mix with the negative and positive. I think this will be let you having to get more clear results. Okay. Okay. Like I will show you this this function here, the g. Okay. If you would like, you can also draw this in your smartphone or a tablet or laptop. I think in the App Store or in the Google Play, there is I think some app for drawing a graph, and you can check the graph from there and compare your results with your calculus calculation. Okay. 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 So at least by looking at this function g, you get at least the domain exceptions, right? For the domain, it should not be equal 0, should not be equal 1, right? And you can uh, try all the numbers except 0 and 1. So that will be a first thing for our domain. So we can write here, domain is, let me just write this x not equal 0, x not equal 1. Okay? And x should be applicable for all real number. Okay? And then we can find the intercept. Okay. If you confuse what intercept means, intercepts means we need to find the point that is probably crossing y or crossing x like that. Okay, that is x-intercept and y-intercept. So we are going to have y equals 0 and then find which x, and we find x equals 0 in which y. That will be intercept. And in this case, okay, in the question, the intercept, if you want to start with the y-intercept when x equals 0, it is not happening, right? So we can start by looking at when this is equal 0. Okay, the function equals 0. So we can probably take the when g is 0, then we can start to look at the functions first. And we can expand this with this expansions. And we can say that this is our equations. And from here, we get the conclusion for the intercept, that is x is equal half. So at half 0, there will be an intercept. So it will crossing the x-axis. Okay, it will crossing the x-axis. Okay, that is the intercept. And we can check the asymptote. So limit Sx going to infinity of the function. We can check one by one. And we know that from the form that you see here, it will resulting with 0, right? And we can confirm that the y equals 0 is our horizontal asymptote. Okay. Okay. And then another confirmation is our uh, from our domain, right? X0 and X1. Maybe that will be the vertical asymptote. We can also check. This will be resulting in infinite, right? We can say that X equals 0 will be our vertical asymptote. Let me move a little bit. And limit as X going to 1. This will be resulting also infinite, but you see that it has negative something big. It should be negative infinity. So X equal 1 is our vertical asymptote. Of course, you can check from the right, from the left, from the right, from the left. Also here, you can check with the negative infinity also. Yes? Hmm? Oh, this negative and 1, this is 1 over 0. It's infinite, but it's negative infinite, right? Okay. Okay. If you want to be more precise, you can think from right, from left. Uh, like for example, 0. Maybe you can check from 0.1, right? Okay. Or maybe negative uh, 0.1. You can also check with that. And imagine your point putting here. If you check from 0.1 from the left, it's going to be a negative, but it has a squared. So something divided by something like having more zero, it will be a big number, right? A big number. Okay, and you get this is also something big there. Also, you can check with the from the right and from the left. This also you can check from positive infinity, negative infinity. Okay, you can check with maybe a big number and the negative and change with the negative with that number and see the results. I think for this result here, it will resulting 0 because 1 eventually this one here is not really sufficient to run with the other number that is really big, right? Okay. Okay, now we have all these three asymptotes, the horizontal asymptote, the vertical asymptote, and it will be our first clue on how to draw the graph. So you can draw the graph with the asymptote. I think y equals 0 and x equals 0. You don't need to draw because it's on the y and x axis. You can make a line on x equal 1 for the vertical asymptote. Okay, you have all this. Okay, next thing you can do is you can check the first derivative and second derivative. We can check when the function is increased, when the function is decreased, and we can check the concavity. Okay, but this is actually a little bit complicated in the process. But let me show you first, okay, and then we can have more discussions. Okay, and I think I will not show this kind of function in the exam. It's quite complicated if you want to look at. But it's doable. We can do some calculation here. So let's start with let me write again the functions is 1 over x squared minus 1 over x minus 1 squared. from here we can get the first derivative, and this will be x minus 2 ddx. This will be having, so it will be negative 2 over x cubed, and this will be also similar with having the cube. Okay, and we need to make this equal 0 to check the critical point or critical number. Okay, I think I can still do it here. So x minus 1 cube, it will be having 1331 for the coefficient, right? So negative 2 x cubed minus 3x squared plus 3x minus 1. Positive, negative, yeah. And then plus 2x cubed. Okay, and then we can cancel this, and we get 6x squared, 6x plus 2. Okay, now we can look that this is, first is there any solution from here? If we check the quadratic formula or just the determinant, this will be 6 minus 4, 6, 2. Okay, this will be 36 minus 48. This will be negative 12. So the solution will be an imaginary number, right? So we can say that no real solutions. And probably we can conclude from here, no critical point. But we still need to check the increasing or decreasing, right? Still need to check. How to check? We can take, we can take the line number and checking the x value that we already suspicious in the asymptote, which is the x equals 0 and x equal 1. So this will be the asymptote, right? This is the asymptote. Okay, we can check in between this point. Checking with the negative number. If we check negative 1 here, negative 1 here, it will be positive, right? If you check in between 0 and 1, checking with the maybe 1 over 2, so 6 over 4 minus 6 over 2 plus 2. 6 over 4 will be 3 over 2 minus 3 plus 2. So it will be negative 1 plus 3 over 2. It should be positive. But if we check with the 1 over or 2 over 3, or by looking at the x cubed here, I still have 1, negative 1, negative 1, negative 1, negative 2. Yeah, negative 1 is positive. Yeah, correct. If we have half 1 over 8, this will be negative, negative, positive. The bottom is negative for 0 to 1. So positive divided negative, this will be negative. You can check this. You can check. Not f prime. G prime is 6x squared x cubed x minus 1 cubed. Okay, checking through this equation and checking 2. Of course, this will be positive. 2 is positive also, so this will be positive. So we are getting increasing, decreasing, and then increasing. Okay. Oh, and remember, in x equal half, it will be crossing, right? It will be crossing. So it's decreasing, but need to be crossing this half thing. Okay. Okay. So the next thing is we need to know the concavity, how the graphs looks like. Because if you have increasing, you can probably having to between this or this, right? But probably the right one, probably here. Why? Because we have the asymptote, horizontal asymptote, y equals 0, and x equals 0. So the probably the only way we can think of is this one. So probably here. But we need to check this middle one here. We are not having any clue how this can be drawn. Okay. So next thing is second derivative. Okay. So let me move to the next paper to check the second derivative. Okay, anything that maybe you might ask or have any discussion here? Okay, if no, then let's move to the next paper. Let me write again the g prime x. This will be uh, and then we derive this. Okay, we derive this. I think the derivative is it become 2 x 4 and become negative, and x minus 1 4. Sorry, not 2. It's 6. Yes, you have to have 3 multiplied by 2. It's 6. Okay, and then we can take this and simplify the form, make it together, combine these two, we get 6. Now we have order 4, okay, with the power of 4. Okay, okay now if we have x minus 1 is 4, we can have coefficients, and if it is negative, it should be alternate sign, so it should be positive, negative, positive, negative. Okay. Or we can also have, if we have the uh, we can also try to check from and then checking from here, we get 6. and this will be having the, it will cancel, so we have only the x cube. Oh, it should be, let me check. Should be different sign. Yeah. Okay, now this should be equal 0. So imagine we have the functions. Okay, how to check the solution from cubic formula? Let me give you the idea. Okay, first you can check the n coefficient and the first coefficient. Okay, so factor of 1 divided by factor of 4. This is possible rational solutions or rational zeros or root. This will be plus minus 1. This will be plus minus 1, plus minus 2, plus minus 4. So you will have plus minus 1, plus minus half, plus minus 1 over 4. This is the possible answer solution for the cubic. Okay. Okay. Now this part here is not really calculus. This is more in general mathematics. But let me show you uh, to solve this kind of problem. Okay? If you have found a polynomial in high degree formula. Okay. So you now have at least 3 possible. Okay, 1 half and 1 over 4, and we have positive and negative signs, right? Okay, we can also narrow down our possible answer. If we look here, we see the signs. Okay, see the signs. So negative here to positive, we say there is one change. Okay, from positive to negative, there is another change, and from negative to positive, there is another change. Okay, so we say from here, there will be 3 positive roots or 1 positive root. How do I know this? This is called the Descartes formula or Descartes rule to find the possible root from a polynomial with the integer coefficient. So 1, 2, 3. So this will be 3 roots, and you need to minus 2 or 1 root. Okay. That's how the rule. And how to find the negative? We check with the negative x inside, and this will be 4x cubed plus 6x squared plus 4x plus 1. So if we look here, there is no change, right? It's all positive. This we can conclude there will be no roots for negative. Okay? So we can conclude that from this 1/2 and 1/4, we can check only the positive number. Okay, because our possibility is only positive number. Okay, this is called the Descartes rule. And how to check? We can check with the. I'm not sure if you learned this before, but let me show you. So let me draw, or let me write -4, 6, -4, and 1. This is polynomial division or syntactic method. First, we can check 1. Okay, check 1. This is plus. Okay, so we will have a negative value at the end, not 0. So it still has a remainder. So this is 1 is not our solutions. Okay, we try another one. -4, 6, -4, and 1. So maybe try half. We try half. So this will be -4, it's -2, it's 4, it's 2, it's -2, right? -2, it's -1, so it's 0. Okay, so at least we get, okay, we get this half here will be our, so x equal half is our root, okay, is solution. Okay. Okay. Now, how do we see this? Okay, if you have x cubed, it should be having x have a 3 number, right? x1, x2, and x3. But we know that there will be only 3 a positive root or 1 positive root. Okay. So because this one is impossible, and also if you check the other 1/4, it's also impossible. If you check this will be impossible, and I think this will be not resulting any 0 here, right? So this will also impossible. So the other two solutions, x2, x3, probably with this will be imaginary solutions or a complex. Okay, but that's not our problem in this question. Our problem is we need just to find at least one x that is make the functions equal 0. And we can conclude that this x here, the x equal half, is our inflection point. Okay. Okay. And then if you look here, then we might need to, okay, then we have the half. Okay. Let me go back to, I'll copy this first. Okay. Or maybe this from here. Let me copy this to here. Resize. Now we check the second derivative, the g double prime. If you check from the negative, let's say -1, You check -1. It should be 6 minus 6 over 2 with power of 4. It should be positive, right? Should be positive. And check another one. Maybe 1 over 4. So it will be 6. And this will be 1 over 4 squared minus 6. And then half mean 1 minus 1. Okay. This is okay. This will be, I think it will be really big on the left, right? 3 over 4 should be 200 something divided by 3 with power of 4 should be less than the left. So this should still be positive, right? Okay. I just do some quick calculations here. Not really necessary to find the number. Okay, and then try the between half and 1, maybe 2 over 3, maybe 2 over 3. Try 2 over 3. So 6, 3, 4 divided by 2, 4, 2, 4 is 16. So something divided by 16. And this will be 1 over 3. Oh, so the left is less now, right? Because it's divided by 2, and the right is not divided by 2, so it should be less. Should be negative. And you can try check the number if you want. If you want to use calculator, that's okay. And check 2. The one on the left, of course, it will be less than 2, 2, 2 minus 1. Yeah, the one on the left will be the less. So it should be negative, right? Okay. So from negative infinity to 0, it will be going concave upwards, and then concave upwards, and concave downwards, concave downwards. Okay, now we have all the information necessary to draw or to sketch the curve. Yeah. Okay. Okay, before I switch to another paper, any questions maybe from the online students? Anything to discuss? Yeah, I believe the difficulty here is the cubic, the formula for cubic. Okay. And the way I show you here is just basically solving this cubic here, solving this cubic here. I'm not using, there is a cubic formula if you look for a cubic formula, like a quadratic formula, but it's cubic. I think it's too complicated. So I just show you how to find solutions. At least narrow our, basically, you can check by try some number, right? Trial and error. Check 0, check 1, check 2, check 3, maybe check 4, and then, but it will be not really having any goals, right? So by doing some checking with the possible roots, okay, to check the possible roots, you can check the n of the coefficient divided by the first coefficient and check the factor. Okay. Factor of 1 is just 1, which means 1 multiplied by 1 is 1. -1 multiplied by -1 is it's also 1, right? And factor of 4, 4 we have 1, 4, right? And 2, 2, right? So 1, 2, 4 is our factor from 4. So the possible ratio in every polynomial with the coefficient, with integer coefficients, it should be factor of the n coefficient divided by the first coefficient. It's always like this. And it should be, if you divide, this will be minus 1, plus minus 1 over 2, plus minus 1 over 4. And then we can narrow it down again because we have two signs, positive and negative. and checking the signs. Signs change. We have 1, 2, 3. We have 3 variations, right? Three change in sign here. That means this will be having 3 positive roots or 1 positive root. You need to minus 2. So if you have maybe 5, maybe it's really long, like higher degree. If you have 5 positive roots, then 5 or 3 or 1. Okay, you need to minus 2, minus 2, minus 2. Okay. And for negative x here, we can check to find in which we need to check whether it has a negative root or not. And surprisingly, we have all positive, which means there is no change, right? There is no change like this one, negative, positive, negative, positive. So the second one here is all positive, which means we have 0 roots for negative. So we can ignore this negative here and check only positive. So we only have 3 trial and error. And I think that will be narrowing our answer. So we check the synthetic deficient. We check synthetic deficient here. Checking 1 is not correct. And maybe we want to check 1/4 first and it's not correct. And then you get the answer at the x equal half. And that will be our inflection point. Okay, I think we already have all the information that we need. And we can switch to draw the graph. You draw the curve. You sketch the curve. Okay, let me write the conclusion from the first derivative test. This will having 0 and 1. This having positive, negative, positive. And second derivative, we have this will be positive, positive, negative, negative. Okay. From here, we can draw the graph. Okay. Okay, let's start with the, this will be 0, x equal 1. Let's say this is 1. And this 1 in the middle here is our 1/2. Or maybe 1/2 is here. Okay. X equal 1, x equals 0 here, and y equals 0 is the y-axis. So that will be our asymptote. Okay. So we know that from negative infinity to 0, it should be having positive slope. It's increasing, okay? But it's concave upwards, right? And I think just by looking at this slope positive, we can conclude that it should be like this. By looking at the asymptote here, right? It's obvious that it should be like this. Okay, place like that. That will be the first sketching on the left side. Now looking at the middle part here, it should be a negative slope, right? At the middle, it should be negative slope. It should be negative slope. Let me draw this. Should be negative slope, and it should be crossing the half, right? It should be crossing the 1/2. Okay, and then you know that the 1/2 is our inflection point. And from 0 to half, this part here, it should be concave upwards. It should be like this. So it should be maybe this. Okay, it should be this. And half to 1, it's still going down, still in the decreasing, it's still decreasing, and it should be changing, becomes concave downwards. So concave upwards and then downwards. Okay, so this will be from here, okay, until there, until this half. So remember that half 0 is our intercept, right? Base our calculation in the beginning. And then, okay, maybe not too smooth, maybe like that. Okay. Okay, so this will be concave upwards, right? This will be concave downwards. Okay. Okay. And then the last one, if you look at after x equal 1, it's concave downwards, but in the increasing decreasing path is positive. So you need to have a positive slope, okay, but concave downwards. So this part here, you need to have a positive slope, but you need to have concave downwards. But remember the asymptote. Remember the asymptote. So you need to start from here and then going down. Okay. So by looking at this graph, okay, if you have first, you know the domain, and from that domain you may find maybe there will be a vertical asymptote, okay, and you can check also the horizontal asymptote. You can make this asymptote as your first base of the graph. Okay, so the increasing, decreasing, and the concavity, they will follow the asymptote actually. So how you draw is actually you increasing the functions, but you need to follow the asymptote. Oh, the asymptote here is y equals 0 and x equals 0. So it's increasing, right? And then you confirm with the second derivative. Oh, it's actually it's upwards, and then okay, it's pretty obvious here, right? And in the middle, we know from the decreasing path it's all negative, but we may have at this point 1/2 our inflection point. Right? So from this inflection point, we need to change the concavity. So it's going down from this asymptote here. It's going down, and then change concavity at half, and then becomes downwards, and it's going to getting close to the asymptote x equal 1, and then it's becoming like this. Okay. And then in the right side, we need to also think, because it's positive, right? The slope is positive, it's increasing. So we need to think that there will be a curve. Okay. Well, it might have like maybe from here, but we need also to think that there will be asymptote one more. So asymptote y equals 0, asymptote x equal 1, and then you need to have a concavity concave downwards. So it should be, and it's getting close to asymptote, and then that's the curve. Okay. In your drawing, it doesn't need to be really smooth. It doesn't need to be really smooth, but you need to show at least your curve needs to get close at certain point, get close to the asymptote, get close to asymptote, and see the difference between this concavity here. And showing this is inflection point, the half is inflection point, and I think that's it. That's it. So if okay, if in the test or in the exam you need to draw, then this is how you draw. And I think I cannot make it like a like a your previous quiz, the online quiz, because this curve sketching you need to draw manually. Okay. And as I mentioned before, this kind of questions, I believe uh, it's quite difficult if you have this in exam. At least by doing this, you will waste like for maybe more than maybe 1 hour if you are maybe not having any clue on how to solve the concavity. Okay, so yeah, not a typical question for exam. This is for practice. Okay, for practice. Okay, now I'll give you another example. Okay, another example. Okay, let's say that you have to the functions is 1 plus e to the x. But try this one. Okay. Try to sketch the curve. You can check with the graphing calculator if you want how the graphs look like. Let me give you a few minutes to check and try to calculate. Can also write this. Okay, first, if you look at the domain, I think no problem at the domain at all. So all real number is okay, right? Because the function is positive functions, right? It's a positive functions because all possible x that you can think, it will always be positive because it has squared, right? And also this e is always positive, so it's always positive functions. All real number is possible. Uh, if you check the intercept, this function is cannot be zero, right? So we can only have when x equals 0, the function will result in this is half, so it should be 1/4. So at 0, 1/4, this will be the intercept. So the curve will cross this point. Okay. So because it's possible on all real number, probably there will be no vertical asymptote, right? No vertical asymptote. And then for the horizontal asymptote, we can check. Okay, let me move to next slide. So vertical asymptote, we can check with limit. First, we can check the positive infinity. And I think this will be resulting in 0, right? So y equals 0 is our horizontal asymptote. And then limit x negative infinity 1 over. This is resulting infinity. Right? Okay. Okay. Do you know why? Do you remember the graph? Okay. Let me draw the graph here. The e with power of x is like this, right? Maybe yeah, like that. E with power of x. If the x approaching infinity, f of x is also going to have infinite, right? If x is going to negative infinity from here, is f of x is going to 0, right? So this part here is becoming 0. So this will be, oh, sorry, why I'm writing infinity. So it should be 1. Okay, sorry. So limit x for the e to the x is going to be 0. Or you can think this as is actually this, right? In limit, this will be 0, right? In limit. So y equal 1 is horizontal asymptote. So we will have 2 horizontal asymptote. Okay. Okay. And then we can have derivative test. So we can check the first derivative is negative 2, 1 plus e x, and this will be negative 3, right? And then multiply with the chain rule, e to the x. Or we can write this negative 2 e with power of x divided by 1 plus e with power of x negative 3. Oh, no, y negative 3, sorry. 3. And again, if you check whether it has the critical number, if you check the critical point, this is not possible, right? This equal 0 is not possible, right? Because e will always be a point. And if you check here, because e to the x is always positive, this is always positive also. So the function is always decreasing, right? The function is always decreasing. So we can conclude from here that the functions is always decreasing because the first derivative is always less than 0. Okay, so whenever you have e, okay, whenever you have e will always be a positive. Okay? It will always be positive. You see the curve e going to have all positive. Okay, and this part here, the denominator, because e is always positive, it's plus 1, and it's cube, it's always positive, right? Positive, positive. The only thing that is making the signs change is this negative 2. So the first derivative will be always less than 0. Will always be negative. So the function is always decreasing. Okay. Now from here, we can check the second derivative. From here, we can check the second derivative. Check the second derivative. You can check from, I think you can make a product rule from this one or a quotient rule from this one. Either way, it will be the same result. Okay. Maybe just do the product rule. Okay. I will just do the product rule. So 6, this will be e to the x, and 1 plus e to the x, and then minus 4, and then multiply with e to the x, plus, or maybe minus 2, 1 plus e to the x, maybe 3 e to the x. This will be resulting uh, say 2e to the x, so will be 1 plus e to the x negative 3. Oh, maybe 4 because it's negative. It should be better. So 3 e to the x minus 1 plus e to the x. Right. Then we can write this 2ex and then this will be 2e x minus 1 divided by 1 plus e 4. Okay, I think correct, right? Minus 2e to the x minus 2e to the x. If I'm using the oh yeah, it's correct. Okay, yeah. Okay, now we have the second derivative, and if we want to check this equal 0, this part here is always positive, this part here is always positive. So the one that is we are going to check is the 2e with power of x minus 1. 2ex should be equal 1. Or we can say that e with power of x should be half, or x is equal ln half. Probably the ln half will be our inflection point. Let me write this, probably inflection point. We can try to check. Okay, we can try to check. Checking this ln half. Checking something that's 0 or positive. If we check 0, it will be resulting with positive. if we check with the negative, it will be let's say if we check the negative, 2e or should be positive here. Sorry, should be positive, should be negative. If we check with x, maybe x is -1. Okay, it will be 2 over e, right? And the inside part, this will be -1. E is 22.7 something, right? So it should be less than 1. So it should be negative, right? Should be negative. So it should be concave upwards, concave downwards. It's going up and it's going down. Oh, wait. Wrong. This should be going down, should be going up. Okay. This should be downwards, upwards. Okay. Right. It's okay, I will draw on the right side. Let's try to draw the curve. Okay. Let's say this is y equal 1, y equal 0. And we may have the ln half is actually ln 2, but minus, right? So minus ln 2 is maybe around, if this is 1, or maybe I will make a little bit small, maybe here. Here. So this will be 1. This is 1. This is half here. -1. So maybe this is negative ln 2, right? So we will have, so before negative ln 2 or ln half, it will be concave downwards. So maybe until there. Okay. And then forget the intercept is, what is the intercept? Was 0 and 1/4. So 1/4 is maybe around here. So this is 0, 1/4. So that's our intercept. So we will change the concavity and make sure that we are going to cross this 0 and 1/4. And it will be going like that, or maybe getting closer to the asymptote. Yeah, more or less this will be the graph, how the graph looks like. So it has the downwards concavity, upwards here after the ln half, and it need to cross this 0. Okay, so this is the intercept, and this will be the inflection point. Okay, and again, you mentioned the inflection point, mention the intercept, and mention the asymptote, and make sure you draw the concavity correctly. Okay, I think that should be okay. Okay, and any questions? Any questions? I think this question much more easier than the previous one, right? Or no? Is there any local max, local min? I think no, right? Yeah. If you look here, if you look here, if you look here, from this statement here, because the function or the first derivative is always negative, we will never reach 0, right? So we will never have any critical point. So maybe we can also write there will be no local max or local mean, okay? Because the function is always decreasing and the functions never reach the the slope never have any horizontal slope. Okay, but this kind of question is maybe possible to do, right? Or no? Or no? Okay, okay. Okay, let me check. Well, I think one more example to see how the how you can try which part here? Oh, okay, maybe this. Is it okay? Okay. Okay, we can take one more example, but yeah, just take one more example, and maybe later tonight, maybe I will give you some more practice. Maybe like 6 to 8 uh, functions that you need to draw. Okay, and yeah, yeah, I think that should be okay because chapter 4 we still have indeterminate forms, the L'Hopital rule, the optimizations, also the Newton's method. I think 2 weeks should be enough to solve or to explore all that uh, sections. So by the end of November, we we might have the our midterm because uh, the schedule from university should be this week and next week, this week and next week, right? But I think we can just delay a little bit, make sure all the chapter 4 we have done and we have understand, and we can have I think a better schedule for midterm. Okay, let me give you another function that might okay, let's say we have of functions of okay, let's just start with this just e to the x and then divide by x squared. Okay, let's start by this. Okay, so uh, I've given you the e, okay, like from previous example also e, because e and ln are uh, both are inverses, so the graph will have similar property, okay? And also an ln there will be certain domain that you need to be careful. Okay, aside from the e ln, for the graph also you might think of the trigonometry. So for trigonometry, because the x you might have some pi or in pi or in radian. So you might think this uh, the sine or cosine or tangent that the most popular. You need to be able to know the basic property like the symmetry. Okay, symmetry. The trigonometry have symmetry. And I think I will include that in the practice. Also, I will make additional video for you how to solve some problems. So maybe it might help for you. Okay. Maybe I will prepare maybe four questions about the curve sketching. Okay, we can start from the domain. Domain, we can start with this is x not equal 0, or we can say this is our domain, right? And there will be no intercept, right? Because if you want to make y equals 0, there is no x possible. If you want to make x equals 0, it's not possible because 0 is not in our domain, so it's not possible to have intercept. So the curve will not crossing any axis. Curve will not cross any axis. Okay, check the asymptote. There will be yes, this one. Yeah, because there will be no intercept. If you check if this is 0, there is not possible because e to the x is always positive, right? If x is 0, it's also not possible, right? Because x is not having any 0 here because of the domain. So if you draw the curve will not cross y or x axis. Okay. Yeah, this is not possible. So let's try the another limit here. Now we know that this will be resulting 0, right? This will be 0. So y equals 0 is our horizontal asymptote. And probably the x equals 0 is our vertical. Let's check the results here. And of course, it's getting infinite. So x equals 0 is our vertical asymptote. And checking the first derivative, I will make the quotient rule. So I have this as our first derivative. Let's make this equal 0 to check the minimum or maximum point. And I think we will have a critical point here. So this will happen. So let me write here. This is always positive, right? So x minus 6 equals 0. So x will be equal to, so this probably our critical number or critical point. Okay. And if we check, uh, by using the x equals 0 and x equals 2, because this is our asymptote for vertical, and this is our probably our critical point. We can check. If we have 1, then there will be a negative here. We check 3, this will be positive. If we have negative 1, it will be negative by negative. It will be positive, right? It will be increasing if we use the negative number to check the f prime. So increasing, decreasing, increasing. Okay, check the second derivative. I think this will be a little bit long. So e to the x. Okay, let me write here. And minus 3x squared, and then e to the x, x minus 2. Plus 1 minus 3x squared, x minus 2. Oh, wait. I think I've done wrong here. This should be having the x minus 2. This is plus e to the x, and then you need to calculate this with the 3x squared. So this should be okay. I think this should be better. This will cancel. Hmm. I think I've done something wrong here. Plus plus x. Oh, right. Right, right, right. Yeah, because x cubed. Yeah, yeah, right. Yeah, I thought this x squared. Okay. Now, okay, I think we don't have much time left. Okay. Okay, I will get back into this later. We will have the feedback time, okay, for today. I will stop presenting for now. Okay. Okay. I think this is around two. The total will be 2 minutes, around 2 to 3 minutes. So this is just a short question, very short question. Okay. Okay, please join in the feedback time. Okay. Okay. You ready? Let's go. Okay. Okay, are you ready now? Okay, let's start the. Okay, let's have 3, 2, 1. Let's start. Okay, 15, 14. I hope you get it correct. Okay. Oh, okay. Okay, that's okay. That's okay. Yeah, let's go. I don't know what happens, but let's go to the next round. Okay, 3, 2, 1. Let's start. F increasing. Okay, look at the graph. Carefully look at the graph. Okay, 3, 2, 1. Okay, okay, good. Okay, okay. Okay, I don't know what happened. I will check later. Okay, question 3. Start 3, 2, 1. Yeah, around 2 minutes, I think. Yeah, I think a little bit calculations. Not really that long calculation. Okay, 4, 3, 2, 1. Okay, I think it's okay. Okay, so who's the winner? Yeah, we'll check later the winner. Okay, so yeah, that's the end of our class. So hopefully we can see you very soon next Monday. Okay.